Hello there, my name's Richard Lamb. I'm the Training Manager at the UK Climate Impacts Programme, or UKCIP for short. Since 1997, UKCIP have been exploring how we will adapt to our changing climate, and we're based at the University of Oxford. In this presentation, we're going to explore the UK Climate Projections, or UK CP09, and we'll look at the modelling that underlies them. Creating UK CP09 has essentially followed a three-step process. Step 1, modelling the climate uncertainty. Step 2, assessing the quality of model outputs. And Step 3, incorporating other climate model results. And we're going to explore each of these steps throughout this presentation. But before we do that, it's worthwhile understanding where UK CP09 has come from. The first UK climate scenarios were produced in 1991 and since then have been published at regular intervals. Each version has become more detailed, building upon our improved scientific knowledge and our increasing computing power. But perhaps most importantly, over time, the stakeholder requirements have changed, going from a very academic exercise in 1991 to the present day where anybody with an internet connection can access the 25 terabytes of data that underlies the projections. So what's new in UK CP09 besides greater accessibility? Well, the main change is a move from a deterministic model to a probabilistic one. But what does that mean? In UK CIP02, the model said there will be this much change. For example, 3 degrees of change. But the UK climate projections say that there will be a range of change. And not only does it say that there will be a range of change, it ascribes a probability to that range as well. The range is where the power of UK CP09 comes from. Because if we have an adaptation that works with the range, it's more likely to be a successful adaptation over time. In UK CIP02, the model was run just once to produce the outputs that you have probably seen. In UK CP09, the big difference is that the model is run over 300 times, and each time the model is run, some of the 31 parameter values are altered within plausible limits. If we were to look at all of those outputs, it might look something like this. The problem is we don't know which model version to believe. So what we can do is we look at all the results in a 30-year time slice and we map them onto a graph. We can then use that graph to group the number of models that project a certain size of change. The problem with this is that it doesn't tell us anything about how good each model version is, and that's what we look at in step 2, where we assess the quality of the outputs. The only way we have of assessing the quality of a climate model is to see how well they simulate the observed climate. So we do this for each of the 300 model runs within UK CP09. It's assumed that models which are better at representing past climate will be better at representing future climate. The importance given to each model version is altered based on how well they represent current climate and recent trends. This can be used to estimate a probability density function, which is the starting point for the probabilistic nature of UK CP09. Within the previous climate scenarios that UKCIP have published, there's always been a statement that recommends users look at other climate models, especially where climate factors are important to a large investment decision. This has been difficult as access to this data is not always easy, so in UK CP09 this information has been incorporated. Here we have some of the outputs from the other global climate change models. Their results are all quite different from the Hadley Centre model, which is the one we've been using up till now for UK CP09. The Hadley Centre model is known to be quite dry, and as you can see from these graphics, the other models give different potential futures for the UK. Other climate models are based on single runs rather than the multiple run approach adopted by UK CP09. So the results of these single runs are incorporated into the results of the UK CP09 modelling process. And here we can see that some of these results increase the overall range for UK CP09. Incorporating the results of these other models has the effect of modifying the shape of the PDF. In this example, the upper end of the curve is extended by the incorporation of these results. It's the final curve that gives us the probabilistic climate projections that form the basis of much of UK CP09. And it's this data that you can access online through the user interface and is used to create all the maps, graphs and charts that you can see online. In this section, we've shown how the modelling for UK CP09 has been developed. We followed three important principles, the first one being that UK CP09 is based on a spread of model results and not just a single model run. The second principle is that the quality of each model run has been assessed based on the observed climate. And finally, we've incorporated single results from other climate models, and this has produced what we now call the UK climate projections. Well, I hope you found that useful. Remember that understanding the principles that underlie the climate projections should help you use them in an appropriate manner. What we have shown you today is a simplification of the modelling process, and if you'd like to explore it in more detail, have a look at Chapter 3 of the UK CP09 Land Report, which can be downloaded from the UK Climate Projections website. There are other resources available to help you explore the full extent of the climate projections, and they can be found on the UKCIP website.